Newton's laws. Vocabulary terms: inertia, Newton's first law, Newton's second law, Newton's third law, and the gravitational interaction. Objectives: to state and apply the three laws of motion, to state and apply the law of gravitational interaction, and to know the variation of g with altitude. As an introduction, until the 17th century, scientists shared Aristotle's belief that a force was needed for motion to continue. So they believed that no force, no motion. However, in the 17th century, thanks to the works of Galileo and Newton, the causes of motion were better understood and accept today that no force, no change of the state of motion. So let's take the example aside. Newton's first law says an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line or constant velocity, unless acted upon by an unbalanced force. So if you consider here the state of this man on the bike is actually in motion, and there are forces acting on it, and still it's in motion. But the point is that the forces acting on this object are balanced. So we have normal reaction of support and the weight. So the forces here are balanced. So though the sum of forces is zero, still the object moves at its constant speed. However, what happens is that when this object hits the wall, or this obstacle of blocks, the obstacle here exerts a force on the bike, stopping its motion, and that's why the man flies out of his bike. So, and I'm going later on to explain why does the man flies in this direction out of his bike. So no force, no change of the state of motion. So when the sum of forces was equal to zero in the first figure here, okay, the object remained moving at the same speed, and it kept the same state of motion. However, when an external force was exerted on the object, and this external force is an unbalanced force that is not opposed by any other one, so now that the state of motion of the bike changes, it stops. Concept of inertia. There are basically three types of inertia, but what's the concept of inertia? Inertia is the resistance of any physical object to any change in its position and state of motion. This includes changes to the object's speed, direction, state of rest. Inertia is also defined as the tendency of objects to keep moving in a straight line at a constant velocity. The tendency, not the real continuing of keeping the same speed. It's the tendency to keep moving in the straight line at the same velocity. We're going to explain this in the following examples. So there are basically three types of inertia. Inertia of rest. The inertia of rest is that considered when the object is initially at rest, and it's the inability of a body to change by itself its state of rest. Okay, this is the inertia of rest. If it was not subjected to any unbalanced external forces, it doesn't have the ability to change, so it keeps itself at rest. Now, for example, in this case, I would like here to add something. If it was initially at rest, as I said, if there are no unbalanced forces acting on it, so it remains at rest. However, if an unbalanced force acted on it, it will react in a way trying to keep itself at rest. Okay, so here, for example, we have a coin put on a piece of, let's say, cartoon that is covering a cup half filled with water. Now, initially, the initial state of this coin is resting. So it was at rest, a state of rest. Why was it a state of rest? Because it was under the effect of two balanced forces, which are the normal reaction of support and the gravitational force. Now, when this person tries to pull the piece of cartoon from beneath the coin, friction now is exerted on the coin due to the rubbing of the two bodies against each other, due to the rubbing of the cartoon against the coin. So now we have a horizontal force, which is the friction force, acting on the coin. So this force is not balanced by any other horizontal force. So now what happens is that the coin is going, and this friction force is tending to move the coin horizontally, because it's not balanced by any other force, so it's tending to move the coin in horizontally. What happens is that this coin tries to resist this change in the state. How does it resist this change in the state? It tends to move downwards. Why does this happen? Because it wants to remain at rest. Now, it tries to stay at the same position where it was, but now there is nothing below it except air, and air cannot hold it. So that's why it keeps moving downwards to the bottom of the cup, where it again becomes at rest, but it goes down under the effect of the gravitational force. So when someone pulls the paper or the cartoon from beneath it, it tries to stay in its place. Oh, it looks around itself and finds that, or it looks downwards and finds that there's nothing holding it, so it goes downward due to the gravitational force, and then again becomes at rest at the bottom of the cup. So we could give here another example that's similar to this one. If you watch the video that I asked you to watch on YouTube, another example was given about the plates that are put on a piece of a cloth on the table, and when the magician tries to pull this piece of a cloth, the plates go upward, move upward a little bit, then go downward again to their initial position. So this external force exerted by the magician by removing the piece of a cloth from under also the plates. The plates are going to respond to this trial of change in the state by resisting it and retaining their initial position. Here it works out because the table is still below them, supporting them, so they again retain their initial position. What I want to say here is that every object has inertia. Every object with a definite mass has an inertia, and this inertia is the resistance of this object to any external physical trial, or in the trial to change the position and the state of this object. Sometimes this inertia or this resistance is strong enough and helps the object to keep its position or its state, and sometimes this inertia is not strong enough to resist the external factors or the external forces that are trying to change its state. So in the example here of the coin, the inertia of the coin was not really strong enough to keep it in the same place, because there was nothing supporting it from below, and the gravitational force was strong enough to move it downwards. However, in the example of the plates on the table, when the piece of cloth was removed from beneath them, the inertia of the plates tended to keep them on the table, and they succeeded in doing that, in retaining their initial state, which is a rest state. Now, so we said that another example of inertia of rest is a person sitting in a car that falls backwards when the car suddenly starts. It is because the lower portion in contact with the car comes in motion, whereas the upper part tries to remain at rest due to the inertia of rest. So the point is that the car is trying to move forwards. So moving forward, tending to change the upper part of the body to this position too. But the inertia of the body tends to, no, I want to stay where I was. So the back or the upper part of the body actually goes backwards as a reaction or as a resistance to the force trying to move it forwards. So that's why when a car starts moving, for example, at a high speed, the person sitting in it goes backwards. However, if this car keeps on moving until it suddenly stops, okay, now the man or the one sitting in the car would move forwards actually. Why? Because it was initially, now its initial state is forward motion. So when we stop it, we are the man's body or the person's body will no, please, I want to keep moving in the same direction that I was moving in. So that's why the body moves forwards a little bit, then goes back and continue or stop just as the car stopped. Okay, but as an initial response to the external force, it tries to resist it. It tends to resist it. Okay. So inertia of motion is the inability of a body to change by itself its state of uniform motion. So, for example, when a moving car suddenly stops, the person sitting in the car falls forward because the lower portion of the body in contact with the car comes to rest, whereas the upper part tends to remain in motion due to inertia of motion. So this is just the example that I explained before. We can take the example of the car. When it starts from rest, this is an example of inertia of rest. When it is moving and then tends to stop, this is an example of inertia of motion. So the point is that did it or was the initial state rest or a state of motion, and that's it. Okay, but the principle is the same. The object or the body or the inertia of the body tends to retain its initial state. Now, inertia of direction, it is the inability of a body to change by itself its direction of motion. So when, again, we have this car moving on a straight road, then it reaches a point in which it has to move on a U-turn, go through a U-turn, changing its direction of motion. Now, it's able to do that due to the friction exerted by the ground on the tires and so on. So there's an external force that's changing the direction of motion of the car. And suppose that there are passengers sitting in this car. So just like the car was moving forward, these passengers were considered to be moving forward with respect to the ground. And thus when the friction force along the U-turn is exerted on the system, moving it and changing its direction, the passengers or the inertia of the passenger's body tend to keep, no, I want to keep moving straight like we were doing, or we want to keep moving straight like we were doing before. So we feel that, or they feel that when they're moving along this U-turn, that their bodies move a little bit like to the right in this case, trying to keep moving in the same pathway that they were moving before they move around the U-turn. Okay, so the inertia resists the change. Okay, it tends to let the body keep moving or or stay at rest if it was initially at rest. Okay, or to keep moving in the same direction at the same speed, or in other words, at the same velocity. So this is the example. When a car moves around a curve, the person sitting inside is thrown outwards in order to maintain his direction of motion due to inertia of motion. So outwards through the right windows, to the windows to the right, okay, because in this case بيصير straight pathway, initial pathway to the right of motion. So here it is. So if the car was moving here, then now this is the right side of the car. So the person or the passengers sitting there are going to move in this direction, tending to keep the same pathway. So now what's the mass? The mass in physics is quantitative measure of inertia. So inertia actually depends on the mass of the body. More mass means more inertia. So mass is the quantitative measure of inertia. It's a fundamental property of all matter. It is in effect the resistance that a body of matter offers to a change in its speed or position upon the application of a force. So the mass, actually more mass means that if this body is subjected to certain forces, external